Okay, hello out there. I'm trying to do a Titan 200M 5-axis learning as I go video. I did do the 139. I think we did it as a 4-axis and we programmed it as a 5-axis. So when you look at the part, you do 5 sides as a 5-axis, but you still have to do a 6-side. And I would do that at the end. As 4 sides, you would do, let's see, 4 sides first, holding it from the end, like a dovetail or some kind of clamping fixture. And then when you take that off, cut off the dovetail part, mill one side, flip it over, mill the other side. So it's sort of just adding one more operation on a 5-axis. But teaching it should be the same way. I know we want to make parts in our class, but I'm actually doing the course here, and I went into the, courses, 5-axis, 200, and in the cam section, he goes right to the second side. The idea here is to machine the top of the trophy and do the bottom just like you did in the 139. Only he kind of left us in the breeze there. So I'm going to actually try to catch up on it. Okay, we have a model here. And I'm going to go to the manufacturer side. First day of my new hands. I actually already programmed the second side, just like Titan had it. And I'm going to do operation 1. Now, we have a chunk of material like this, right? And the plan would be, could you machine the whole thing in one chunk? You got to kind of make these decisions. Now, this part is about 9 inches long. So if you were to try to machine everything, and you could program it like that, you would need to hold on to the bottom. And you need extra material on the bottom. And the options would be a dovetail, which you have to prep and do a dovetail. And that holds pretty good. Or some kind of extra material that like a 3-jaw chuck could hold, or a self-centering vise, something like that. So it's possible. I'd say anything's possible. It's a matter of rigidity. So he was suggesting that we do this side first and then put it in the vise, holding on to this, and machine the rest of it. So I'm actually going to do it like that, split up, and I'm actually going to try to do it as full one operation. All right. So if you're do the block first, you still get your material. So what I did is, if I hit the home view, this is my view. So I'm just going to flip it upside down, right? Doesn't really matter which face is where, but so I kind of got ahead of myself. I started to do the setup. So in my setup, I go right to select Z and X or Z and Y. And I like the model box point idea because that really means we're in the center and we have to shift down a little bit to get to there. Or if you do stock box point, that means you just, let me click it to stock. It's actually much easier setup. You don't have to shift, but this would be dead center in the middle. So if you had this, let's say, facing you, and you're clamped on the bottom here, and you want to do 5-axis, which means you got to machine the top and 4 sides. And I noticed this has corner radiuses on it. Now you could do 3D mill them, but I noticed in the tool library he had a corner radius, or what we call a corner rad tool. And I'm going to show you how to use that. Let's see. So what I did is pick Z up, X to the right, but when I go to the, if I have the, where is it here? sync view, and once I click on this, it'll whip around in the view that I'd be machining it at. And with the other thing I did, instead of using relative size, I just do fixed size box, and I try to pick standard sizes. I believe this part is pretty close to 3 inches, so I made it 3.25, and I made it a little bit longer, 9.25. So if you had square material and you cut it off at 9.25, that'd be a good representation of the stock. And here I'm also going to put in my Titan 200M1. And I'm going to call this WCS1. I just want to get in the habit of doing this for the multiple work coordinates. All right, so that is set. All right, so from this point of view, we could just do a normal face mill on the top. Something we already know how to do. So I'll go 2D face, I'll go select, and I downloaded the Titan library. But up here is the ones I'm working on, so I already did this one. Let me go into the Titan library right here, cloud. And he's got a 4-flute, 3-inch face mill, and his defaults. He does spend a lot of time on the RPM settings, but I'm actually going to try to plug these in so we have some numbers. But here's the tool list right here. You got face mill. This is the corner radius tool. Small ball end mill. 1/2 inch. This is called a bull nose or a corner radius tool. Here's another one that's a ball end mill, a bigger ball end mill, and the old chamfer mill. I'm just going to use the feeds and speeds that are in the machine here. We're not going to get big into this area. We just want to learn how to do this. Okay, because stock selections have been decided. Tool orientation, we probably want to start doing this now on all operations. So I'm going to do select Z and X. This is going to be Z, and let's see, X-axis, oops, will be something in this direction, and then flip it. All right, so that's done. Z up, X to the right. As far as if you pick stock height, that's always going to be the safest clearance moves. Bottle top will be the finish line. We're going to do multiple depths. The standard 40 thousandths is fine. I would add a finishing step. By default, it puts in the finish feed rate that you had in the other one, but you have control of that, but I wouldn't get into this too much. Chip thinning is actually considered to be an adaptive style of leading into a part, and it's not as aggressive. It's kind of subtle. I'll have to teach you more about that. Here's one here you always want to use, extend before retract, because when it goes to go off the part, it won't go all the way off. I always make sure I turn that one on, and then hit OK to see what we get. Okay, so this is wider than the face mill, so we got to take 2 cuts. All right, that looks fine. I think I'm going to do the face mill on all the operations, and then we're going to do the corner radius tool, and then we can do the engrave the features. All right, so we're going to go, let's see. Let's duplicate this one, right? Now we're going to tilt, all right? So this is our view here, and we want to go like, I'm just going to use this tilt this way, right? So this will be facing out of the machine, and when I do the simulation, the vise will be on this end, and I'll have to add that in there later on. We're going to machine this side right here. All right, so that means we got to change tool orientation. So we're going to select base will be that, and x-axis we want to face to the right. So let's pick something that goes in that direction. Okay. The only thing is nope. Z is the top, and I picked the wrong one. And this is X. So Z is face. Yep. You don't have to have it on the top, as long as you know where it is. So when this thing tilts, it's going to know where it is. You just want to make sure that Z is up. and X is to right. Oh, let me get this one more time. Flip. There we go. Okay, everything else has been set, so this should do it correctly. The only problem is, as tilted, see if this works. It's trying to do everything because it's trying to look at all the material. So the face mill operation is kind of dependent on stock. It's trying to think of this whole thing. And we don't want it to go down here because we're going to be clamping here. So we can limit that a couple of different ways. One would be actually make this smaller, or he was using like building a line and using that as our guide. So I'm going to use that way. Let's go back to design. We're in the same orientation. I'm just going to flip it so front is facing me. I want to draw something on this face. And, oh, it looks like I got some lines from before. Yes, I do. Oh, these are from previous ones. That's from the other side. Let me see if they're in here. Nope. I'm just going to draw it in. Sketch a line. And I want it to be, it doesn't have to be that exact, because you want to be the face mill somewhere across here. So I'm just going to draw a line from here to there. We're just going to call that our boundary. Hit escape. New sketch. That would be this one here. Whoops. Turn it on. Okay, that's going to be our guiding line. Manufacture. Back to here, right? You really can't use face mill when you do this because we're going to use contour. So we're going to delete this one here. Delete. We're going to use 2D contour and just use this as our guide. All right, feeds and speeds are from the previous operation. We have contour selection this way, and we're going in this direction. Let's see. Orientation, let's get that done. So we want Z to be this, and X to be that way. Okay. And we got, let's not use selected contour. We're going to use model top, which is going to be the top of this. Or you can use selection. All right, we're going to use multiple depths. Oh, clean this up a little bit here. Multiple depths, finishing step down. Let's just do one. Oh, what's that? Does it say how many? Oh, that's 40 thousandths per. Okay. 1 at 8. Rough final. I'm not sure what that means. Okay. Hit okay. See what we get. All right. Remember, this is trying to treat it like a roughing profile. And what's our warning here? All right, so we want to get rid of all these lead in, lead outs, or modify them. I'm going to change this to 0 degrees. Horizontal lead in radius is going to be 0. Vertical lead in 0. And that's linear, so I leave that alone. Hit OK. And now it's more like a straight line on the lead in. It's on the wrong side, though. Let's see. Edit. Geometry. And we want to make sure this is on that side. Okay, multiple cuts. Now we're going to do a pattern because it's all exactly the same. We could do the same thing. We'll make 4 different lines. But knowing that this is a perfect cube, we can use pattern to our advantage. So I'm going to say add new pattern to what we have here. And it's going to be circular, meaning that it's going to rotate in a circle. I already have 4 instances lined up, so we already know what the pattern is, and just want to know the axes to rotate it around. So we need to turn the origin on. And we got to rotate around the blue line. There we go. And let me look at this. Nope. Okay. And let me close all of these up. Go back to Op1. That's the top. And let me do the rotated one. So you really let me tilt this. I've gotten in the habit of saving views as we go along. So I got Op1. This is my second side, and this is my first side. So this is my rotated operation 1. This is C0 and B90. B90 means it rotated down. Okay, so we got face mill on that side and face mill on this side. Only I'm not sure if this might need 2 cuts. So let's change the contour, edit, and roughing passes. That'll be sideways. Hit OK. I think we want to stretch it a little bit more. Edit. Maximum step over. Not sure it's doing what I want it to do. Anyway, let's see what we got here. That'll be all 4 and pattern, right? Let me do a quick simulate. All right, start simulation. Looks like it'll work. Let's go back to the beginning. Simulate again. All right, so machine the end, machine the sides. So why do we have a big chunk there still? Let me look at the model. I guess, yeah, there's still a hefty amount of the radius there. So let's edit this. Roughing pass. Let's see. Let's step over. Okay. Oh, now it's stepped over a ton. Got 2 cuts here. All right, let me I'm gonna change this to a very small number. I think that'll work fine. Let's go simulate again. Remember, in the simulation, it's not going to flip the way you think. Yeah, probably add a couple extra cuts, but not a big deal. All right. There'll be a lot of extra material there. Transparent, toolpath, stock. That's weird. You would think this would be green. Or okay. Maybe it's just these settings I have it on. All right, let me just add, I'm going to skip the engraving part, but I'm going to go right to the ball or the corner radius tool, which is actually just contouring. Contour, select 139. So I'm going to use the, what the heck is it here? Corner radius tool, and hit select. And I'm just going to zoom up on this tool here a little bit. It's the shape is, we call this a form tool. Ooh, let me see if I can use my other Titan mouse here. So it's the radius is going to match the radius that's on there. All right, so we're going to use, let me just switch this to tool orientation. If you do set up WCS, that means you're already aligned to that way. So you can leave it just as that. Geometry, we're going to select those boundaries right there. I'm going to shut this stuff off. Selected contour. And minus 0.125, I believe. And I'll leave everything else alone. Okay. If this generates, looks like it's inside. So you hit edit. Oh, I think I need to be here. So if that's the case, leave this at 0. There we go. This may need some roughing, but we can find out. And here's a boo-boo I just made here. Oh no, it's working out right. If you do patterns, make sure you don't keep on attaching them. They'll be linked to your pattern. So, all right, let me just simulate that one. See if that comes out right. And step 1, 2, 3, 5, and then press play. Oops, what happened there? All right, so there's that corner radius tool. I'm trying to figure out still why we're getting this extra blue material here. So, but that's probably got to do with my face mill operation. All right, so we need to do these other ones. So that'll be, let me go flip this way. And we're going to attack it from this way, which means we're just going to go, we don't really need to go around there twice. We could just do this line and that line. All right. You can duplicate that operation because that's the same. Going to change orientation. DX. Want that face to be Z. And you want pointing to the right to be X. And geometry is now going to be, you can pick that line. It just goes around again, but I get worried about blending, but all right. And these will 3D machine. All right. Is there anything else I need? I don't think so. So that one we can also make into a pattern. All right, so you got circular. Axis, the blue line, and it's going to be 4 times. Flip direction does not matter. You know, in a way, you don't really need to do it 4 times, but. So let's simulate one more time, all right? I think I took too many cuts on the face mill. Better to be safe. You're better off taking more cuts and replacing stock. Oh, we got a collision here. That's actually, it actually, if you think of it like a chamfering mill, it works the same way. I don't think that's a real collision. As far as the simulation goes, it looks pretty good. These blue things. Unless they get machined later. So that would really complete, without doing the engraving, Operation A, I guess they would call it. So when it comes to post time, up here, I'm going to use the legacy style first. So we want to use the next generation post. I got it already labeled 1001 and 200M. And right here, you want to click this, and we're going to use UMC 750. And until I update my post processor, we want to turn on, we're on preload tools, yes. Use G0, we want that to be on. And we want DWO. And what's the other one? I like to get rid of sequence numbers. So I want no sequence numbers. Post. Save. And make sure the code comes out right. Yep. So we got right there. Titan 200M, Op1, tools. And right now it has the, these are unclamp axes, rotate, clamp, turn the coolant on, machine, get tool 2 ready. This will be machine, and this goes and it actually goes to home, flips, and starts machining and flipping. Okay, they'll actually have B and C rotationals. All right, it's about 28 minutes, but I think it's well spent. So then I'll get on to, I really did the 55 Op2 side just like Titan did it. So using this multi-axis, and in this one, it's actually flow already has multi-axis in it. Let me turn that on. There's been some upgrades since then. Right here, flow. Oh. Right here, steep and shallow and flow have the multi-axis switch. And later on, we'll learn to use these other ones. The other ones will be a 3+2 strategy. So, okay, talk to you later.